Hello, Math 133 students. I've received your request for help with this question, which is section 5.3, number 22 in my math lab, or my stat lab. Okay, it says, for a parallel structure of identical components, the system can succeed if at least one of the components succeeds. Assume that the components fail independently of each other, and that each component has and it says 0.24, but I'm going to view an example here, so I'll do the example problem. So each component has a 0.27 probability of failure. All right, so first thing it wants to know is, would it be unusual to observe one component fail or two components fail? All right, so let me go here. I've put this in here, right here. Okay, so the first question is asking, the probability of failure is right here. So that's the probability of failure. Matter of fact, I'll even put that. So they're saying, would it be unusual for one component to fail? Well, no, because unusual is defined as less than 5% or less than 0.05. So it would not be unusual for one component to fail because the probability of failure which is 0.27 is above 0.05. Okay, well that part's simple enough, right? So is this unusual to fail? No, right? But that's why they never put just one in a system. That's why it's got identical components. So it's a little strange because there's so much negative language in there. It would not be unusual for a component to fail because the probability of failure is 0.27. Then it's talking about two components. Well, they're independent of each other. That's key. So since they're independent of each other, then the probability of both components failing is what we're talking about. So the probability that both components fail is the probability of failure times the probability of failure, right? Because they're independent. Well, that would be 0.27 times 0.27, which I have decimals right here. 0.27 times 0.27 is 0.0729. Just on a side note, if you're thinking, hey, that's 0.27 squared, that's correct. But if you're going to do squaring, make sure you hit Shift 6 to make it, or hit the A to the B button. That too has to be a power, not 0.27 times 2 on the outside. See how the 2 is in line with the other numbers? That's multiplying by 2, and that's wrong. So it's 0.27 to the 2. Just a little side note for you. All right, so this was 0.0729, which is still not unusual. So it would not be unusual for both components to fail, as the probability of both of them failing is 0.0729 is above 0.05. Right? So compare this 0.079 to this 0.05. Since 0.079 is greater than that, then it's not unusual. All right, so we answered those questions. Ooh, I don't like that at all. There we go. All right, what is the probability that a parallel structure with two identical components will succeed? Oh, before I get to that, let me double check here. So if I go back to this question and I click on the continue of the example, you can see what I was saying. So there's the 0.27, which is not unusual. There's the 0.0729, which is not unusual. Okay, so now we want to know, what is the probability that a parallel structure with two identical components succeeds? All right, so we want two identical components and we want to succeed. And remember, it succeeds if at least one of the components succeeds. That's key. All right, so let's think here. We want to know the probability of success, right? Okay, well, the probability of success is the probability that at least one component succeeds, which according to our rules is 1 minus the probability of, this is rule number 5, both fail, or let me hold this, probability of fail to the 2 power. That's probably not good for you guys. Here, let me insert an equation. That way I can make the power look like what you want. All right, so 1 minus, sorry, that was my dog thwapping, if you could hear that, fail, and she's now whining at me, to the 2 power. But we already found the probability of fail to the 2 power. It was 1 minus 0.0729, which is, all right, so let's go over here. 1 minus 0.0729 is 0.9271. 0.9271. So that's the probability right there that we have success, because success is at least one of them succeeds. So that would be the answer. All right, for now for the real fun one, right? So how many components, right? This was 2 components. So if you'll notice right here, there were 2 components on this one. I'm running out of highlight colors. So there were 2 components on that one. So now they're saying how many components would we need to have some kind of success? Well, okay, so again, the probability of success is the probability that at least one of them succeeds, which is 1 minus the probability of failure to the 2 power if there's 2 components. But that would be, here, if I want to write it up here, just real quick, that was 1 minus, when you think about how we got this, it was 0.27 to the 2, right? Because that was the probability of failure. Okay, so, but it was 2 components just because that problem worked that way. But what they're asking us here is, what number would I have to put here? What would n be in order to make this work? In order to make this be, the final result be 0.999. Right, that's what they're asking. They want to know what number I have to put in there for the n. Right? They want at least one success, so they want no failures. Well, to do that, all you have to do is go here and say, look, instead of 1 minus parentheses 0.27 to the 2, right? That's what we did for this one. I mean, I did it in 2 steps, but we did 0.07 or 0.27 to the 2, and then we took it away from 1. So instead of breaking that down, what if we just do it like this? And instead of 2, we put different numbers in here, and we just see what works. 3 is not high enough, right? 3 is not getting us 0.9999. So you make it a bigger number. How about 4? How about 5? How about 6? Right? And you play around with it until you get the highest number you need. So let's go 7. Oh, there we're getting close. 0.99989. That's close. So let's go 8. There we go. 0.9999. There it is. That's the one. So that got us the 4 9s we were looking for. So if you look at again, 7 isn't quite big enough. It's got 9 9, but then it has an 8 for that 3rd position. Sorry, I want to hide that keypad. So I'm going to go to an 8 here. That's going to make it, right? That's got the 4 9s in a row. That's what we're looking for. So it's 8 for us, right? Every problem will be different, so you can't trust 8. It's not going to be the answer for everyone, but that's going to be the answer for us on this one. So if n equals 8, the probability of success equals 0.9997, I think it was. There we go. So 8 is the answer. That's our final result. And again, that's the way you do it, but of course every problem will be different because the probability of success will be different for every problem. 0.27 was what it was for this example. All right, I hope that helps.